Hi everyone. In this video, I'm going to show you how to graph linear inequalities. So I list out the steps, okay, and I believe there are six steps. So what is the first step? So let's go over the first step. The first step when you're given a linear inequality is to solve for y, okay? First, you want to solve for y, and second, you want to rewrite the inequality as an equation, okay? Then graph the line. That's step 3. Now, step 4. Okay, so sorry, for step 3, make a solid line for when you have the inequality less than or equal to or greater than or equal to. Okay, solid line. And you want to use a dash line when you have the less than or the greater than inequality symbol. Okay, step 4, you want to choose a point on one side of a line. Let's say the point 0, 0, okay? And then you're going to substitute the x and the y value. So you want to substitute the x value and the y value of your chosen point. And for me, I use the origin 0, 0, okay? You're going to plug that into the original inequalities, okay? Then you want to shade the region area, uh, shade the region area where the point is located when the inequality is true, okay? If not true, shade the other region, okay? And I'm going to show you what I mean by step 6. So after you plug in the x and y value of your chosen order pair or points into the inequality, and if the inequality is true, so you want to shade the region where the chosen point is on the x and y coordinate grid, okay? But if the inequality is not true, you want to shade the other side, like the other side. You want to shade the section where the point is not there. Your chosen point is not there. Okay. If it doesn't make sense, I'm going to show you an example. So let's do an example. So make sure you have a step down. So please pause the video and write down the steps if you have not done so before. So as you can tell, so this is our first example. Y is greater than 6/5 of x, 6/5 of x plus 3. So how would you graph this linear inequality? So the first step, you want to solve for y. The y is already solved, so I don't need to solve for y. Okay, so make sure you have your steps that I ask you to write down. If you don't, yeah, make sure you have your step on the side. So I'm going to go through the step one by one. So we already solved for y. Step 1 has been done for us. Now, step 2, you're going to rewrite this inequality using the equal sign. So let me use on my right side. So I'm going to write y equal to 6/5 of x plus 3. Okay, so now the m is a number in front of x, which is 6/5. So the rise is positive, so I'm going to go up 6 times. And the run is positive, so I'm going to go to the right 5 times. And where am I going to start? I'm going to start at the y-intercept. And what is a y-intercept? The y-intercept is a constant. And we call constant the number by itself. So the number by itself here, positive 3. So I'm going to write here positive 3. Okay, so b equal positive 3. So where do we start? Always start at the y-intercept. So I'm going to locate positive 3 right here on my y-axis. So I'm going to place my pencil my pen right there, okay? Then what am I going to do? I'm going to go up 6 times. Let's do that. So I'm going to go by 2, so 2, 4, 6, okay? Then I have to go to my right 5 times. So I'm going to count that twice. So 2, 4, and then 1, so it should be 5. I place my dot right here. So I have 2 other pair. So I cannot continue forward, but I can go backwards. Okay, what can I do? How can I build the line on the left? Again, you go back to the y-intercept of y equal 3 here, and you're going to go backward. So instead of going up 6, you're going to go down 6. So let's do that. So 2, negative 2, so 2, 4, 6. Okay, 2, 4, and then 6. So this I'm down negative 6. No, I'm down negative 6. Why am I doing this? I want to build a line on the left side. So I'm taking the direction of the slope by using the opposite. So instead of going up 6, I'm going down 6. And instead of going to the right, I'm going to go to the left 5 times. So let's count. So this is 2, 4, and 1 more is 5. So I have the 3 dots is enough. So I'm going to use my ruler and connect the dot. So before I connect the dot, okay, you have to do step 3, okay, and you have to use a solid line if you have a line under the inequality. Okay, since you don't have a line under the inequality, you're not going to use a solid line, so it's going to be a dash line. Okay, so I'm going to use a dash line because we don't want to include both the solutions cannot be so on the line. That's why we don't want the solution, uh, the solution are not going to be on the lines. Okay, why? Because we don't want to include those other pair as the solutions. So you want to use a dash line for this. That's why you visually to show that, okay, you don't want to include the other pair on the line are not part of the solution for these inequalities. So I'm going to include the arrows on the ends. Why? Because the line continue to go on the left and on the right forever. And to represent forever, you use an arrows on the left and the right. Okay. Next, you want to find out which region to shade. Is it going to be the line? So the region above the line or below the line? How do we find out? That's why you need to go to step 4, and you're going to choose a point on one side of the line. Okay. The point that I personally like to use is 0. Okay. So my chosen point is going to be the origin 0, 0. So what is going to happen? I'm going to go back to this inequality, and wherever there used to be, remember, this is the inequality. Okay. So now guess what? Wherever there used to be the x, I'm going to plug in 0. And there, for the y value, I'm going to plug in 0. So I'm going to write here 0 is greater than 6/5. Okay. So now any number times 0 will always be 0. Okay. And then I bring down the plus 3. Okay, so now let's add 0 plus 3 is 3. So let me ask you, okay, can 0 be greater than 3? Is 0 greater than 3? Is this inequality true? No, it's never true, it's false. So because this inequality is false, okay, I cannot shade the region, okay, or the area where the point 0, 0 is. Okay, so I cannot shade this area. So which area am I going to shade? So I'm going to shade the other area, the other region where my chosen point is not. So I'm not going to shade this. Why? The inequality is not true. So I'm going to shade this area right here. So you can take a color pencil that you have, and you want to make sure you shade this area. So now, which means what do I mean by shading this area above the line? What does it mean? So basically, it means that any other pair in this region right here above the line, okay, but not on the line because you have a dash line, okay. If you were a solid line, you want to include both other pair, okay, on the line. But because since you have a dash line, you don't want to include both the other pair on the line as solutions. They have to be right here, okay, on the left side of the line, above the line. Okay, any other pair in this region, okay, will be solution to the inequality. Okay, is a point 0, 0 solution to this inequality? No. Okay, it will never be true. Why? Because if you choose any point right here, it will never make this inequality true. Okay. So if you want me to, if you can check, you can. So let's see what I mean here. Okay. So let's say if you choose, let's say you want to take the point, this is 2. Let's say the point 2, 1. So if I take 2, 1, okay, the x value is 1 and the y value is 1. No, the x value is 2 and the y value is 1. So let's plug in. So the y is 1 is greater than 6/5, parenthesis of x is 2 plus 3. So I have here 1 is greater than, so 12, okay, I'm going to approximate 6 times 2 is 12. So 12 divided by 5 is going to be about 2.4 plus 3. And then you have 1 is greater, and then I'm going to add those two numbers. So I have 5, 4. Okay, can 1 be greater than 5,4? Never. It's false. So you see here that any other pair that you choose, sorry, I chose this other pair here, 1,2. So if you choose any other pair away from the not in a solution area, not in a solution region, okay, it will make this inequality false, okay, and I shows the point 1,2. So any points in this solution region but not on the line with this solution, okay, we make this inequality true. And you can also pick any points, pick a like exact point, maybe this point here, this point right here, okay, and you will see that after plugging them into the inequality, it will not be true, okay. It's only those points that are located here in the solution area, solution region, that will make this inequality true. I hope this video is helpful. I'm going to make another video, okay, to for graphing a linear inequality. Okay, bye.